Jasmine Good, and I am going over lab report number 6, part 1, 6-1, the truth table. So for this one, it's a little bit more complicated. We have a 7486 chip, and then we have a 7408 IC chip, and then we have a 7432 IC chip. So it looks overwhelming, but we have switch 1, switch 2, switch 3. So the input of switch A, which is going to be number 7, is this yellow wire, and it's going to be going to the pin 4 of 7486. So I put on the bottom so we could put the more complicated wires across each one on top, so I put the main connections on the bottom. So that's input A and B for being pin 1, and then pin 4. And then I have the C in, which is going to be a blue wire just for a visual effect, going into pin 2 of a 7408. Yes, and then that's going to carry in. So then from there, we have the two outputs, which is LED 7 and 6. LED 7 is going to represent the sum that's coming out, and that's going to pin 6 of the 7486. And then we have the C out, which is the other red wire going through, ending in pin 3 of 7432. Okay, and then the output of the first 7486, which is on this side, the bottom, is going to be from pin 3, and then it connects to pin 5. So it's that little yellow orange wire connection. So that's from the first 7486 to the second 7486, and that makes that connection right there. And then we have pin 2 of that 7486 chip connecting to pin 2 of the 7408 chip. So those two connect, as well as that pin 2 connecting to pin 2 connecting with the red wire to pin 9 for that 7408 chip. And then we had pin 1 connecting to pin 4 of that 7408 chip. So that's another connection right there. And then we had pin 4 of 7486 connecting with this orange wire to pin 10 of the 7408 chip. So those are all the entry wires that go through. And then from all the connections from the 7408 chip going into the 7432 chip, so that I can make that final C out at the end with the red wire. So we had pin 3, and then we had pin 6, and then we had pin 8 as well. So yep, we had all those as the outputs connecting towards pin 1 right there, and then we also had pin 2, and then those made those connections. And then we also had the ground running with the green wire going into each IC chip for ground, and we also had the VCC running from the top with this black wire right here going to tops, making sure it's connected all the way through. So for this, we had 3 inputs, which is A, B, and then the C in, and then we're looking for the C out and sum being represented with the LED. So turning it on, when switch A, B, and C in are low, a 0, there should be a sum out of 0 and a C out of 0. So then when we switch it to being switch A and B at low and then 3 at high, we see that the sum is 1 and then the C out is 0. And then when it's low, high, low, low, high, low, it's gonna be that sum 1, C out 0. And then we have low, high, high, low, high, high, and then we're gonna have the sum of 1, sum of 0, and then C out of 1. Then we have high, low, low, and then we have that sum being 1 and the C out being 0. Then we have high, low, high, high, low, high, and then we're gonna have 0 as a sum, and then C out being 1. Then we're going to have high, high, low, high, high, low, and then we have sum being 0 and C out being 1, and then we have high, 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 meaning sum and C out should be a high. So this is how a full adder should represent itself.